All right. We're going to be going over the Chapter 6, Part A, 6.1 through 6.4 practice test. First one, whenever there is multiplying and dividing, you always want to simplify with a fraction exponent. So what I'm going to do is I'm going to rewrite this. Square root is the 1/2 exponent. And then I'm going to simplify inside here first. So this would be like 1 over 25, which actually I'm going to rewrite that too, because I can rewrite 25 as 5 squared. Then if I look at my x's, right here, if it's dividing, you're subtracting exponents, it would be going on bottom, y to the 6th. And then I have my power to a power, and don't be greedy, give it to everyone on the inside, y to the 3rd, 5, x squared. Same type of thing here. So first I'm going to rewrite this in a fraction exponent. Square root is the 1/2. 289 is 17 squared. 8 to the 10th. Power to a power, I should be multiplying my exponents. Power to a power, multiply my exponents. There we go. Oh, now I have a little 3 out there. If I have a little 3 out there, that's the same thing as the 1/3 power. And then I'm going to write 64 over here. I am not circling crossing out here, only when you see adding, subtracting. So what I have here is 1, 2, 3, 4, 5, 6, 2. So that's 2 to the 6th, x to the 6th, y to the 9th. And my power to a power, I should be multiplying. So this is 2 squared, x squared, y to the 3rd. Next problem, again, 1/2 exponent. So this would be 5 squared, x to the 14th. If I work up my 81, that is a 3 raised to the 4th power, because there's 1, 2, 3, 4 3s. And I have my power to a power. My final answer would be 5, the 1st, x to the 7th, 3 squared. And my last one. There's 2 different ways that you can do this, 2 different ways. You could either say, okay, what are these numbers? This would be 6 times 7, 3 times 2, that's a 7. And I could raise this all to the 1/2 power. They all have the same index, so I'm going to put them all together. So this would be 3 to the 1st times 2 to the 1st times 7 to the, here's a 7 and here's a 7. So this would be squared. And do it to your 1/2 power. You could do it that way, and then your final answer would be 3 to the 1/2 times 2 to the 1/2. Times 7 to the 1st. Or what you could do, because I saw some people doing this today, is the same type of thing by square root of 42 and square root of 7, and now since it's multiplying, I can work in between them. And I could circle cross out here, so this would be 7 square root 6. These are the same exact answer. And last one on the first page. So first thing I'm going to do, I'm going to rewrite this as the 1/3 power. 27 is 3 cubed. And then I have 8 to the 15th, b to the 17th. And the power to a power, I should be multiplying. So if I multiply these all together, this would be my answer. First page, done. Second page, still multiplying. This is still multiplying here, so I'm going to look at this. They have the exact same index. I'm going to write that as the 1/4 power. Both of these have the 4 index, so that's the 1/4 power. 24. 24 can be rewritten as 2 to the 3rd times 3 to the 1st. Again, here's my 24. That's where I did that. Whoa. And then I have my x to the 3rd. 4 can be written as 2 squared. So what I'm going to do, I'm going to simplify inside my parentheses first, because these have the same base. So this is like 2 to the 5th. I'm adding my exponents here. These have the same base. So my 3 to the 1st doesn't have anything. X to the 5th. Power to a power, you multiply. So 5/4 times 3 to the 1/4 times x to the 5/4. And that's my final answer for that one. Right away I look at this problem, I see that I have adding, subtracting. So one thing I would for sure do, adding and subtracting, is write that on your paper. Because when you have that, you're going to be performing this a little differently. You still do your prime factorization for each number. So this is 9 times 2. Again, you can still do this the perfect squares way if you so wish to. 8 times 4, 2 and 2, 4 and 2, 2 and 2. Looking for pairs, because this is square root, circle, cross out. Circle, cross out. Circle, cross out. I can't do anything with the other two. So for each one, this first one is going to be the same thing as 3, because that's what's circled, that's the balloon, it floats on out of there. Square root 2, because this 2 is left inside. Addition, because I see adding here. And then I have 2 times 2, which would give me 4, and I still have this 2 left inside. Subtract square root 2. One thing that might be helpful is you write a 1 right there. So now, I have 3 plus 4, because these are the same square roots, we can do that. So 3 plus 4 is 7. 7 subtract 1 would give me 6. The answer would be 6 square root 2. First, outside, inside, last. First, outside, inside, last. Again, if this is difficult for you, you should write down exactly what's being multiplied. So first would be 2 times negative 3. If you're doing it this way, put a parentheses and then put plus. It would be 2 times negative 7 square root 5 plus inside 5 square root 5 times negative 3. It's very important that when you do something like this that you are staying nice and organized. 5 square root 5 times negative 7 square root 5. So this would be writing out the long way. So my first is negative 6. My inside would give me a negative 14 because this is a negative times a positive. And I still have my square root 5. My inside would be the negative because I have a negative 15 here. 5 times negative 3. I still have that square root 5. My last is 5 times negative 7 square root 5 times 5. So this becomes a negative 35 times the square root of 25. And the square root of 25 is, oopsies, just 5. So if I multiply those two together, 35 times 5 would give me a negative 175. Again, negative times a positive. These two are like terms, so that's a negative 181. These two are like terms, negative 29 square root 5. That right there is my final answer. Rationalizing. Now this one's a little bit different. You can simplify the top and bottom, or simplify at the end. I'm going to actually simplify this right now. Oops. So I'm going to look at my factor tree. This is 4 times 3, 2 times 2, circle, cross out. So this is the same thing as 2 square root 3 over square root 7. But really I'm looking at the bottom. Rationalize the denominator means looking at the bottom. So multiply by square root 7 over square root 7, multiplying by 1. There's no ending subtracting here, so I don't have to do the opposite. So for this top part, these two get multiplied together. I still have the 2 here, and this becomes a square root of 21. On bottom, 7 times 7 is 49. I know I can't simplify 21 any further because there's no pairs there. So I have 2 square root of 21. Square root of 49 is 7. So that's my final answer. Question 11. So my question 11 is your question 12, and your question 12 is my 11. So be aware of that. I have to rationalize my denominator. So I rationalize my denominator, you're multiplying by the conjugate. So in this case it would be 5 subtract square root 6. 5 subtract square root 6. Both top and bottom. Conjugate because these two numbers are the exact same, but if this is adding, this has to say subtraction. These have to be the exact same right here. So on top, I multiply here, this becomes 5 square root 6. Multiply here, minus the square root of 36. On bottom, just like I foiled before, if you need to, you have to write down each problem, but I'm not going to do that. My first is 5 times 5 is 25. My inside is 5 times negative 1, and then I still have my square root 6. My inside is 5 times positive 1, and I still have my square root 6. My last My last is positive 1 times negative 1, square root 6 times 6. So that becomes a negative 1, that becomes square root of 36, that becomes a negative 1, 6, so this is like a subtract 6. I can simplify the top. This would be a negative 6, square root of 36 is negative 6, plus 5 square root 6. These two cancel. 25 subtract 6 would give me 19. That's my final answer. Divide to simplify. Well, one thing I notice is that they have the same index. Since they have the same index, what I'm going to do is rewrite just one big 1/3 power. You could do this in a different way and still get the exact same answer as me. I like to always simplify my fraction before I actually do the fraction exponent. I'm going to write a 1 there. If there's no number, it's a 1. So, what do I have here? Can't simplify the 3 and the 7 at all. That says it's 3 and 7. The x's, there's more x's on the bottom, so it should be subtracting. Subtracting to get that 4. Okay, y's, there's more y's on top. And again, subtracting. Now you have your power to a power. Remember, if there's no number, this is a 1 there, not doing 3 times 1/3. Final answer, 3 to the 1/3, y to the 1/3, 7 to the 1/3, x to the 4/3. Final page, same bases. So if they have the same base, I'm going to be adding exponents. The base stays the same. Again, the base stays the same. So my base stays at 7. Adding exponents, 1/4 plus 3/4 is 4/4, or that's the same thing as 7 to the 1st. 14. 25 can be rewritten. 25 is the same thing as 5 squared. I still have this 5 to the 1/3. So I have to do this power to a power. So I have 5 to the 1/3 power times 5 to the 2/3 power. And then it's just like this problem up here. Now we get 5 to the 3/3, which is equal to just the 5 to the 1st. Rewrite this in radical format because it's so radical like that. You know what I'm saying? You know what I'm saying? Here's my root. You have to decide, does a 3 or 10 go on bottom or outside? Remember, a root index is a fraction exponent. What makes it a fraction is this part down here. And I still have x to the 3rd on top. 16. So you could rewrite this in prime factorization, but I don't have any fraction exponent, so I do not have to do that. So I'm just going to multiply the 5. 5 times 6, I'm going to get 30. And the x's are the same base, so I do 3/4. Oopsies, 3/4 plus 1/5. And that's where I get the 19/20ths from, because you're adding exponents. You're adding exponents if you have the same base with multiplying. I see a fraction exponent here, so I'm going to rewrite 81. This is 3 to the 4th. You can do your fraction tree if you want to, or factor tree. Power to a power should be multiplying. So this is 3 to the 4/3. 8 to the negative 6. I do not want any answers with a negative exponent. So I have 3 to the 4/3. A, the positive 6. I have to move that sucker on bottom. 18. So I'm going to do my power to a power. Power to a power. I'm multiplying. This becomes a negative 4. This becomes a negative 5. Power to a power. 1/5 times negative 20. 1/4 times negative 20. Again, I don't want negative exponents, so I have to move both of these to the bottom. You have to write this one up here. Otherwise, it doesn't look like a fraction. It just looks like a line right there. And last but not least, power to a power. Multiplying. Again, I would write a little 1 there. This becomes x to the negative 6 over 4 to the negative 2nd. You have to flip-flop them to make them positive. Now, if you rewrote 4, that's the same thing as 2 to the 4th over x to the 6th. I would accept either one of these for this final problem. Bing, bada, boom. Can't wait to grade these tests because I know you're going to get an A because you're awesome like that.